One go. So we're going to look now at using the rhoden shwarts as a signal generator, oscilloscope, and a spectrum analyzer. Over to you, Mike.
Right, so we've used our auxiliary output here. There's a built-in function generator on these scopes, and we're generating a sine wave, 10 kilohertz in frequency, 250 millivolts peak to peak. So we can see that in the time domain. On the horizontal axis, we have our time that we can adjust with our time scale. So if I expand it out, we're seeing the wave in more detail. And then on the vertical scale, and the vertical scale, we have our amplitude, so our voltage. So we're looking at our volts. We can see 0 volts is here in the middle, and then we're going up to 150 millivolts here, down to minus 150 millivolts here. We are showing a 250 millivolt peak to peak, but we have some loss in this cable, and the frequency that we're running, and potentially the world's worst probe. So unfortunately there is some loss there, which is represented by the amplitude being somewhat reduced. Potentially a mismatch in the output impedance of this will be 50 ohms, and then the input impedance of this probe will be 1 meg or 1 meg ohms. So there will be some loss there. So we can see that in the frequency domain, and we can look at that. We think it's beautiful. We're starting here, we're moving across here in time, and this is our amplitude. So we can flick that by transforming that signal into the frequency domain using a fast Fourier transform, which will put the scope into a frequency domain. Now, right back here, because we're at 10 kilohertz, as you can see down here on the scale, it's looking at 4.16 megahertz. So the signal that we're going to be looking at is right down here. So what we need to do is we need to try and change the scale of this frequency domain so that we can see the signal that we're interested in. And that is typically easier said than done. So if I change this here, we're changing the span. The span is the amount of the signal that we're looking at. And then we can change the scale, which is showing the vertical scale here is power in dBm. That represents the amplitude of the signal that we're looking at. And then we should have another one somewhere where we can move this. Here we go. We can expand this out a bit. Let me do that. Yeah. This is the bit which always gets interesting. So we're moving our start position now. As you can see, we start at 0 hertz now, and our stop is at 42. So we now move our center frequency down. We need to move that down. We want to move our span down. Here we go. Okay. Now, if we move our scale up a bit here. Right, so we can see this little signal here that's poking up. If we put a cursor on there, do we have cursors on these rhoden shwarts? We should have somewhere. No, we can have a cursor on there. No, again, not the best of. Let's see if we can put a. So ultimately, any idea how to put the cursor on there, John? Let's have a look. Okay, so we're going to put our cursor